Welcome to this session where I want to talk about how we can use R to run a partial least squares estimation for a structural equation model. For this, before I go into the details, I want to first give you a short idea on what kind of data are we actually working with. For this, I have this Excel sheet open here on the left. And as you can see, there are multiple variables. They usually with some first part and then a respective number. This is actually that there's a construct, the SI or the CCI, the VOM, and there's different items which make up this construct. So in the SI case, there's 3 items which all 3 together make up this SI construct. And that's important to know that you actually either in Excel or in any other kind of data format, save your data in this way. So first, there's some common, term which you can use to denote your respective constructs, and then you number them increasingly from 1 to something else. If you have, like here, 1, 2, 3, or even with the 1, we can see it's like 1, 2, 3, 4, 5. Up to 9, it's not this big of a deal. Once you go beyond 9, you can still number them 1, 2, 3 until 9, and then go 10, 11, 12, and so forth. So you do not have to go with 0, 1, 0, 2, 0, 3. So that's quite nice. That keeps also the thing a little bit easier. Well, this much for your data preparation part. Now we can switch to R and consider the actual calculation part. The first part is nothing special. First off, however, we have to load the package we're going to use here. That's the seminr package. I'm also loading the readxl since I have my data in an Excel file. And this does nothing else than open the file dialog and reads the respective Excel file. I already pre-prepared it, so no need to actually run this stuff here again. But, just to say, you have to get your data into R in one way or another. Then, this part here is the actual calculation, or let's say the first part of the calculation of the application. And what we do first, this part here, we're going to define our constructs. So I'm going to give them some names. This one, that one, that one. You can select them in any way you like. Here I called them SSC since this is data on social shopping communities. And the data goes for data file, con for constructs, rel for relationships, and model, for model. But you can use any other names you would like. I will tell you later where you actually need those names again. Well, let's go with the first part with the constructs. So we use the function constructs here in defining our constructs. Then we have composite, and then here we use or we give the name to the constructs as we are using them in the continuing succeeding model. So that's actually the names you have to use in the next part. Here I use the exact same terms as in the Excel file. Excel file, that's the second part, but you can use different names in those 2 parts. Well, that's the name you're going to set for use later on. Next part tells you where do I get them and what kind of construct do I have. As you saw in the Excel file, I have only multi-item constructs. So constructs which result from more than one item. So here I'm using the command multi_items. I could also include single item constructs. In this case then I would have single_item, so without the S. Here, however, with a standard version of a structural equation model, so everything is multi-items. Then, here inside the brackets, I'm first going to tell him what is the first part of my variable names. So what is the fixed part of the variable names? And then after the comma, I'm going to tell him which numbers to read here. So I always started at 1, so all of these start at 1. You could start at 2, 3, or whatever. I find it a bit easier to start at 1 and then go to the last one to read. So as I had 3 items, so I go as I 1 to 3. VOM had 5 items, so I go VOM 1 till 5, and so forth. You have to do this for all the different constructs which in one way or another are going to enter your model, and only for those constructs. Well, once we've finished with this, defining the constructs we're working with, we can actually use them to build our model. That's what we do with the relationships function. So here we're going to define the different paths of the model. Those paths, I'm going to use one line per set of paths. Always follows the same structure. It goes from to. Then there's like an array of different defined composite constructs. So the names I use here are actually the names I set in the first part of my constructs, not the parts back here. That part refers to the Excel file. This part is used down here for the relationships. I'm always putting them in those quotation marks. And if I go here like those 4 constructs, from those 4 to those 6 constructs, what he will do is he will consider all possible combinations. So all combinations with those 4 and those 6. So he goes SI with the first, with the second, third, fourth, fifth, sixth. Then goes rewards with all 6. Then he goes VOM with all 6. CCI with all 6. So in total he will generate 4 times 6 paths in this situation. So this is quite convenient, so you don't have to write down every path on its own. And well, since this is so convenient, we only have to define 2 sets of paths. This first one, and then this set with 3 here and 3 here. And that's my whole SEM as such. So with this, I defined the constructs. Here I defined how the constructs are linked with each other. Then I have finished my preparatory work, and I can actually go to estimating my model. So here I'm using the PLS, partial least squares, so I'm going with estimate PLS. And then I have to tell him which data set to use. That's data equal to the name I gave here to the data set. Which model to use, or measurement model, which in other words simply just asks which constructs to use. So here I'm going to use the name of the constructs. And then which relationships, that's the structure of the model, which relationships to use, that's the name I gave to the relationships output. Then I have some additional part here on how to work with potential missing values, how paths are weighted. I could set them differently. I would just keep this. The missing values part you might skip as well. Well, once we have defined this model as well, or estimated this model as such, I can just summarize my output and display it. So that's what we're going to do here as well. As I said, the data set is already loaded, so you can just execute this. And then we get this output relatively fast. At this point, I see whether all the preparatory part works out well. So if I have a problem in defining my constructs, or telling him what to take from the Excel file, what's the name, from which to which, he will give me the error at this point already. Same thing with relationships. If I'm using a construct which I didn't define before, he will give me some error message at this point. So at this point he tells me, okay, you have 323 observations, all are valid, so no missing values, everything is in order, and then goes to estimate all of this. So here, that's actually the path coefficients, all the paths defined in those 2 parts. Up here, I get an estimate how much of the variance of each of the dependent constructs can I explain with the independent ones. So it's my R squares for the model. And he also gives me something nice down here. He does some reliability check and he tests or reports Cronbach's alpha, row A and row C, and the average scores. And he also tells me even what are the critical thresholds. So as we can see here, for my data set, everything's in the green. Well, so far so good. But there's one problem. Because while we estimated our coefficients here, we did not get any information about significance. That's a big problem because PLS is inherently a non-parametric method and does not deliver per se any kind of significance levels. But we can use some small, let's call it trick, and simply use bootstrapping to generate our standard deviations, standard errors, and based on those we can calculate confidence intervals or t-statistics, and then based off them p-levels. So how we go about this? Well, we can use this part here, which is simply bootstrap the model which I defined up here or estimated up here. So that's the part here. The whole first part, that's just a new name for my output. And then I'm going to go with bootstrap model. It's an seminr, so using the same part as before. And that's simply the one thing you have to change. That's the name of the model you estimated before. We're going to use 1000 repetitions. You should go maybe with a little bit more, but 1000 works decently well in generating some values here. I'm going to set some random seed part here for the bootstrapping, and I'm just summarizing the results. So I'm going to execute this part as well. This will take some time, that's why I said just 1000. With 5000 will be a bit more, but the results will also be a little bit more exact. Even with 1000, we will see they're already quite okay. Well, now he has this. We have to scroll up a little bit because he basically bootstraps everything from before. The most interesting part is the first part, where we see here every path of the model. He has the original estimations from before, and he has the bootstrapped results. And we see even with 1000 repetitions, it's already quite close. So in some cases, it looks exactly the same. In some, there's a minor deviation on the third decimal. So not a lot of deviations. We get our standard deviation based on the standard deviation, as I said, t-scores, and the 5% confidence interval. So if you need something else than 5%, so you can use those t-statistics to run your own tests and calculate your own p-values, significance levels. Well, that's more or less all there is to this short introductory tutorial. Of course, down here you would get bootstrap results also for how well all of the different items actually load on the respective construct, the estimation for the relationship here, and, well, the loadings, the factor loadings at this point. So I have much more information than you might actually need. And as I said, even with 1000 repetitions, quite good estimates. Well, that's then about it. That's all I wanted to talk about. So I hope you enjoyed it. I say goodbye and see you next time.